Hello friends. Today I am going to discuss on how to build driver and fleet safety with AI. Enhancing driver and fleet safety has always been a top priority for fleet managers, and smart fleet managers recognize that a safer fleet is invariably more productive and efficient. In recent times, GPS tracking systems along with AI and cloud computing have helped to bring greater visibility in operations, thereby increasing fleet safety. However, by deploying an advanced fleet management system, it is now possible to take safety to a whole new level, using the power of artificial intelligence and machine learning. Read on to see how. 1. AI dash cameras. These are wide-angled, high-definition, integrated video cameras that capture sensor-based information on road conditions, the driver's facial movements and his driving behavior. They employ machine learning techniques on historical and live data to predict and categorize events. They can detect all kinds of traffic violations and unsafe driver behavior such as distracted driving, harsh braking, tailgating, rolling stops, etc. All such incidents are categorized and reported in real time to fleet managers via the cloud. Some systems go a step further and give out instant in-vehicle alerts to drivers, so that they can correct their driving in real time. The intensity of the alarm is based on the severity of the violation. By identifying the distance of vehicle on the road ahead, and calculating time to headway, they instantly alert the driver if the distance is equivalent to 3 seconds or less. The system also sets up targeted video-based coaching modules for drivers, based on their own driving history. On the other side of the coin, companies are also using this system to gather evidences of good driving behavior, devise driver scorecards and incentive programs to reward star performers and motivate drivers to do better. 2. Predicting union-safe drivers. This involves the integration of all existing safety systems in the vehicle, viz., telematics, video systems, detailed HR records, driver behavior, accident and collision records, training records, vehicle information and performance data. AI is used to analyze this information and build models around patterns of behavior to predict the likelihood of events. As more data is fed into the system, it gets more and more refined. The end result is a risk score that is assigned to each driver. Managers can drill down to specific safety events for the driver and work out their next steps, whether to go for a coaching call, a training module or face-to-face counseling. 3. Collision detection. The system captures various sensor-based images and data from the vehicles while on the road, along with G-force, gravitational force equivalent, data. When the G-force is high, it would be easy to assume that there was a collision, but in reality, it is not always the case. Machine learning is used to analyze numerous streams of data points and uncover patterns that predict an actual collision at a very high level of accuracy. Detecting a true collision is crucial for fleet managers, so that they can take immediate and confident action on a collision report. Additionally, a comprehensive collision report is generated comprising of vehicle and driver identification, vehicle direction, points of impact, severity of damage, driver injury, location, map view, road conditions, series of events that led to the collision and visual evidence. This detailed information equips managers to take decisions regarding claims and also serves as hard evidence in case of legal issues. 4. Optimized routing. The system analyzes millions of data points on traffic, road conditions, environmental hazards, real-time weather, plus vehicle data to predict risk in real time. This results in optimized routes, schedules and dispatch systems on the go. 5. Predictive maintenance. The system collects raw sensor-based vehicle data across a multitude of vehicle systems, for example, coolant temperature, engine condition, tire pressure, vehicle performance, driver behavior, etc. This data is then married with contextual data such as weather, ambient temperature, maintenance schedules, accident/breakdown/downtime records, etc. AI-based predictive analytics is then used to analyze trends and predict the vehicle fault before it happens. When the system alerts the manager of an impending problem, he then has plenty of time to figure out a response. He can decide whether to get the driver to bring the vehicle to a halt, stop at the nearest service station, complete the route, or disregard the alert. The action taken is also fed into the system, which helps the system to learn and refine its algorithm. The system also predicts and recommends the most effective and efficient maintenance schedule in real time. Fleet managers no longer have to spend on routine maintenance, their maintenance spends become more targeted and focused on predicted and prioritized events. According to a report by McKinsey, predictive maintenance done in this way can reduce costs by up to 40% and downtime by up to 50%. The integration of AI and ML in fleet management is proving to be a real game changer in the transportation and logistics industry. Benefits are far-reaching. Early adopters are rewarded with a new competitive edge, but this is only the tip of the iceberg. Fleet operators are only beginning to understand the potential of AI. Deploying the best fleet management system, companies can leverage AI to potentially save on operating costs, increase driver and vehicle productivity, save fuel, mitigate claims, reduce insurance costs, and even increase service life of their fleet. What's more, in a competitive industry where recruiting and retaining drivers is the biggest challenge, AI can help to keep drivers engaged and motivated to perform better. What more could one ask for? Keep in touch. If ever you need any kind of help, please send us an email at info@fleetroute.com. Get your free demo at fleetroute.com. Please like and share this video as well as subscribe to our channel.